Morning Year 10, what we're going to be looking at this morning is a little bit of Pythagoras Theorem. Some of you will be familiar with this, some of you not so familiar with it, some of you may not even have seen it at all. So I'm starting off quite simple. Your starter this morning is to just run through these square numbers and square roots, because that is what's going to help you working with Pythagoras later in the day. So we've got 5 squared, 7 squared, 9 squared, 10 squared, 11 squared. Calculate. Calculate the square root of 16, square root of 36, square root of 49, square root of 81, square root of 144. Next, calculate the square root of 4 squared plus 3 squared. So you've got to do 4 squared, add it to 3 squared, and then the square root of the result. Similarly, 6 squared plus 8 squared, find a result, take the square root of it. And then finally, just something a little bit different, 13 squared, 14 squared, 15 squared, 25 squared, 5 cubed. Okay? Try and do as much of it as you can in your head rather than reverting straight to a calculator. You will need to be using a calculator later on in the day, but try and do as much of this in your head as you can. If you want to pause the video while you actually do those calculations, that's absolutely fine. When we come back, we'll go through the solutions. Okay, thank you. Right, so 5 squared, 25, 7 squared, 49, 9 squared, 81, 10 squared, 100, 11 squared, 121. What's the square root of 16? It's 4. Square root of 36 is 6. Square root of 49 is 7. Square root of 81 is 9. Square root of 144, 12. What about 4 squared plus 3 squared? 4 squared is 16. Added to 3 squared, which is 9. So you've got 16 added to 9. That gives you 25. What's the square root of 25? The square root of 25 is 5. 6 squared is 36. 8 squared is 64. 36 added to 64 gives you 100. What's the square root of 100? It is 10. 13 squared, 169. Good number to try and keep in your heads. 14 squared, 196. 15 squared, 225. 25 squared, 625. And 5 cubed. 5 times 5 times 5. 5 times 5 is 25, 5 lots of 25 gives you 125. So that's your starter activity. Now we're going to be looking a little bit more at Pythagoras. Okay, if you've got the facility to do this, and don't worry if you haven't, because I'll take you through it anyway. Accurately draw a triangle with a base length of 3 centimetres and height of 4 centimetres. But make sure you've got a right angle between those lines. So if you've got your squared paper available to you, your exercise book, it's easy to create a right angle with that. One side of 3 centimetres, one side of 4 centimetres, right angle between them. Once you've drawn those two lines, complete the triangle and measure your third side, the length of your third side. So that should mean you have something looking like that. 4 centimetres, 3 centimetres, right angle between them. Don't forget that little box in the corner means a right angle, 90 degrees. 4 centimetres, 3 centimetres. What is your new side? If you've drawn that accurately, that new side, your third side, should come out as 5 centimetres. Okay? Now, let's have a little look at that. We've just been messing around with square numbers. 4 squared. Now, we did that with our square numbers. 4 squared is 16. Make a little note of that. 3 squared is 9. What happens if you add 9 and 16 together? It equals 25. Okay? What's 5 squared? Funny enough, it's 25. And that is what Pythagoras' theorem is all about. It only works for right angle triangles, and you must be very clear in your mind about this. Pythagoras' theorem only works on right angled triangles. It's this relationship between the lengths of the sides and what happens when you square those sides. And don't worry, I'll explain that a little bit more. This is what Pythagoras' theorem says. You need to make a note of this. You've got three sides of a triangle, and convention and all textbooks will write it down in a very similar fashion. You make those lengths A and B and C. That C is always the long side. The long side, the longest side of this right angled triangle. That long side is always opposite the right angle. That's always known as C when you read about this in textbooks or anywhere else. The short sides are just labelled A and B, doesn't matter which way around. Basically what it's saying is if you square the size of side A and you add that to the square of side B, add those two together and it equals the square of that third side. So in our example that we've just done, we had 4, we had 3, we had 5. So A squared is 16, B squared is 9, C squared is 25. So C squared is 25, C is the square root of that 25, so it's going to be 5. And that's the relationship. That is what Pythagoras' theorem is all about. Short sides are A and B, doesn't matter which way around. The long side is always C. Square the short side, add it to the square of the other short side, and it will make the square of the long side. That's how it's written in textbook. In a right angled triangle, the square of the long side, called the hypotenuse, is equal to the sum of the squares of the other two sides. So the sum just means added together. Okay? And that's the formula that you need to write down. A squared plus B squared equals C squared. One short side squared added to the other short side squared equals the long side squared. That is Pythagoras' theorem. Some of you will be familiar with that. Some of you, it might be a little bit distant in your mind. But that is what Pythagoras' theorem is about. You need that formula. Maybe even a good idea to write down the formulae in words. That is Pythagoras' theorem. Okay, taking that on a little bit, why do we need it? Pythagoras' theorem. Here we've got a house. It's got a roof truss inside that, where the loft is built. It's based on right angled triangles. The stability of this crane, sorry if it's not particularly clear. Let's see if we can do something a little bit about that. Hopefully that makes it a little bit more clear. Got a roof truss inside a roof in the loft of a house based on right angled triangles. The stability of this big long crane here is based on right angles. The floor plan of this building, based on right angles. A lot of buildings will have right angles within them. So being able to work with right angles when you're doing these designs, when you're working things out, working out what you need, very, very important. Okay, so civil engineering, building, yeah, really important. Construction, building, very important. Mathematics, you need to have an understanding of Pythagoras' theorem to move on within mathematics into trigonometry and to higher maths. Astronomy, surveying, you need to know about right angled triangles. Pythagoras' theorem is a very important part of that. A lot of science, so physics, you need to know about right angled triangles. So it's important to get the basics of this. Let's have a little look at how that works. So I've drawn out another triangle here. I've got a short side of 6, I've got a short side of 8. I'm trying to find my long side. Okay? So my Pythagoras theorem says short side squared plus the other short side squared equals the long side squared. So in this example, 6 squared added to 8 squared equals my unknown. Let's just keep that as c squared. 36 plus 64 equals c squared, which means that c squared equals 36 add 64, 100. So what does that mean? It means that c is the square root of 100, so c actually equals 10 centimetres in this case. Okay, nice and simple. 6 squared plus 8 squared, the two short sides added together equals the square of the long side. 36 plus 64, that equals 100. That is this long side squared, so the long side is just the square root of 100, so it's 10 centimetres. Let's just get rid of that so we've got some space. And have a look at this second example here. It's slightly different to the second example. So we've got our a squared plus b squared equals c squared up there to remind us. So one short side is 5, so 5 squared plus the other side squared, the other short side squared equals my long side squared. I don't know my long side, I'm trying to find it out. So I've got 25 plus 49 equals c squared. So c squared equals 74. I don't know about you, I don't know what the square root of 74 is off the top of my head. The square root of 64 is 8, the square root of 81 is 9. So the square root of 74 is going to be roughly between those. You're going to have to go to calculator to do that, and that actually comes out as c, that long side, equals 8.6 centimetres when we round it to one decimal place. Okay, which is about right, isn't it? 74, it's roughly between our, between our 64 and 81. Square root of 64 is 8, square root of 81 is 9. So square root of 74 being 8.6 is roughly correct. Right, what happens here then? Because here we've got a short side that we don't know. We've got a short side that we know, and we've got a long side that we know. So if we look at our formula, what have we got? We've got a short side, 4 squared. Don't know my other short side, but we do know my long side, 8 squared. So what am I able to say there? I'm able to say 16 plus b squared, my short side that I don't know, equals 64. So that means that b squared equals 48. So b, what's the square root of 48? Square root of 49 is 7, so square root of 48 is going to be very close to that. So if I go to my calculator, square root of 48 to one decimal place is 6.9. So 6.9 centimetres to one decimal place. So what we've done there, what do we know? We know a short side. What do we know? We know a long side. We're trying to find our other short side. So we just work out our equation, which gives us a solution for b, the short side that we don't know, 6.9. Fundamentally, ladies and gents, that is all there is to Pythagoras. Just understanding that formula, knowing what that formula stands for, what it represents. A squared plus b squared equals c squared. The c squared is always the long side. A squared and b squared are the short sides in a right angled triangle. I'll just quickly flick back to the page with the formula there. So you've got that available to you. So that is Pythagoras' theorem. That is what you need to know. Let's get rid of the stuff that I've written around there. A squared plus b squared equals c squared. Right angled triangle, square of the long side is equal to the square of the short sides when they're added together. And that's it, ladies and gents. You'll get an opportunity to do some examples for yourself. Good luck with those. Hope this has been helpful to you. Thank you very much for your attention.